Okay, so 9.1 quadratics and their graphs. We're going to learn more about graphing these. Now, yesterday we learned a little bit about how things move. So in here, one of the things I want to talk about, when things are in parentheses, we talked yesterday how it does the opposite of what you think it would do. So see, that says x plus 3. So if I were looking on x, this is x. X plus 3, what I would think it would do is move the middle 1, 2, 3 to the right, because that's x plus 3. But in there, it does the opposite. That will actually move it 1, 2, 3 to the left. Okay? Out here, minus 5, that actually moves things up and down. So what that's going to do is move things down 5. So there is a fast way. These graphs today are in what we call vertex form. Now we're going to do this. We're going to use our calculator. So it is good to have a calculator. We're going to type things in just to verify this. But what will happen, if you think about these things, one of the goals to figure out the vertex, which is what we're going to figure out first, is okay. So here's one of the things. The vertex, we're just going to kind of jump in. The vertex is going to be at -3. Now why? First of all, the x value. That's the x value of the vertex. It's the opposite of what's in the parentheses. Now another way to look at it, if I put -3 in there for x, what's -3 plus 3? 0. So the goal is to figure out how to get 0 inside there. That'll help you figure out the vertex. So if I put in a -3, it will give me that. But what it's saying is I would move the vertex. Let's remember the basic parent function that we've talked about in the last lessons looks like this. 0, 0, then it's over 1, each way, up 1, and then you get the graph. That's the basic parent function. What we're going to talk about today, you don't have to graph that. If you did, it's not a problem. We're talking about where would this new vertex move? The new vertex would move 3 to the left. But then this gives me the y coordinate, and that one's not opposite because there's no x there. It's not putting anything in. So the new vertex will be at -3, then down 5, and you'll put a dot. And you can see that just by looking at the equation when it's in this form. Okay? So, can you look at the next one and see if you can figure that one out? Now remember, what's inside the parentheses is opposite. And then what's outside is okay. If I look at this, what value would I put in for x to make that 0? +6. And now the y is the same. So what do I put down for y? That one's not opposite. So it's not -1, it's 1. Okay? Now look at the last one. What can I get for the vertex? What? What's the x? -3. You see a 1? I don't see a 1. So what's the number for shake our head? 0. There's nothing out there. That's the number that represents nothing. Okay? So right there, you should be able to look at those and you should be able to figure out the vertex. Okay? Now, the axis of symmetry hasn't changed from what we learned yesterday. Axis has the letter X in it, not Y. So for axis of symmetry, on all of these, we say, well, x equals, x equals, x equals, and it should be staring us in the face because we have an x and we have a y. So what is it here in the first one? -3. What is it here? What is it here? Not 0. Okay. Okay. What's the domain for all of them? All reals, all reals, all reals. Now, as we've done so far, we've always tried to make a little table. Now, I don't know how much room I've given you, but I'm going to make a little table for each of these. And the first number I have for each of them is -3. Now, that -3, that's also the axis of symmetry. It's where you should have put your dot. You can put the dotted line there, you don't, but that's the fold line for this parabola. This parabola, if I draw it, it should fold over that, and the two halves should be on each side. Now, you don't have to draw it yet. We're going to figure out where do I get some other points. Here. Do it. Okay, so now what I need to do is I need to come up with two other numbers to put into my equation. First of all, I'm going to do this. My equation is -2 times x plus 3 squared minus 5. So I'm going to try this in my calculator. -2 times x plus 3 squared minus 5. Now what I've put in here, I've put in -3 for x. Why? That's what I think my vertex is. Now if I've done this right, what should come out is -5. And if you learn how to look at it, it works that way. But now I have to pick two different numbers. Now, if you're using this calculator, if you're not using this calculator, not practicing, make sure you got a chance, go get one of those calculators. If you press up on the calculator twice, it highlights it, and then I press enter and it copies it down. Now, what I want to do is I want to put in a new number, not -3. And I have to decide what to put in. When I drew my little table, what I did is I left some room here and here. And what I'm looking for are two numbers that are on each side, just one to each side of this. What number would be one number to the left of -3? Give me the number that's one number. I'm look at my marker. One number to the left of -3. -4. Good. Not 4. -4. You have to say the negative. The negative indicates a direction. What number is one to the right of -3? -2. So those are the two numbers I want to put in. When I put in -3, I get -5. I want to see what I get when I put those in. So I'm going to type -2 in there now and see what it gives me. And it gives me -7. So I'm going to write that down. When I put in -2, I get -7. I'm going to graph it. -2, -7. Now I'm going to go up and copy this again, and I'm going to put in the other number. I'm going to back up the 2, and I'm going to put in a 4. If I've done it right, I should get -7. The reason is if you go the same distance from the middle line each way, I want one to the left, one to the right, I should get the same number, and then I will feel good about what I've done. If I get that, I know I've done something right, and I'm going to stop. Now, in the early stages, we graph 5 points. Now I'm telling you we can go to -4, -7, and I think that's enough because now I can do this. I can put my graph, and I know it opens down. So my range deals with y. It deals with the -5. Y is less than or equal to -5 because it goes down. Now, one of the things, you can tell how a parabola opens. If it's y equals and you see a negative right away, that parabola opens down. I told you the other day, it's kind of like a frowny face, okay, because it's a negative parabola. But if it's y equals and you have a positive number first, then that's one that opens up. It's positive. Okay? So this one had a negative. It was definitely going to open downward. So how do you think this one's going to open? Up or down? Up. It's a positive. Now the 1/3 might change some things, but we're going to make a table. The first thing I'm going to do over here is I'm going to graph 6, 1. So I'm going to go over 6 and up 1. And again, how did I get that? The 6, I looked here, and if I put 6 in there, 6 minus 6 would get me 0. But the 1, that one's just transparent. It's just automatic. Okay? Gets me a 1, 6, 1. So if I put in the 6 in the equation, what should come out as 1? So practice typing this. Do get a calculator. Okay? Put control divide gives me 1/3. Then I go 6, subtract 6 squared plus 1. It got me 1. That's what it's supposed to get me. Why? I said it was supposed to. The 6, 1, you can look and it's automatic. Now I have to come up with numbers. This 6 is my axis of symmetry. What numbers are 1 to the left and 1 to the right of 6? So 1 down from 6 is what? Just subtract 1. What do you get? 5. 1 up from 6 is what? 7. Those are the numbers I'm going to put in. Now again, if you're not practicing this on the calculator, then we're going to get to the practice. You're not going to know how to do it. So just watching me doesn't always help. It's like when we go to driver's ed, the driver's ed instructor talks to you a lot about driving a car. But if you never drive the car, you're probably not going to pass your driver's license. So driving the calculator, I'm just seeing some of you are driving your calculator, some of you are not, or like 50%. Okay, I go up, I copy this, I put in a 5. It says 4/3. Now, if I don't know what 4/3 is, I take 4 divided by 3, I put a dot, it's like 1.3. So I'd rather use the decimal. When I put in 5, it's 1.3. So I go over to 5, and I go up 1.3. It's a little above the 1. If I've done this correctly, when I put in 6, or not 6, when I put in 7, the other number, I should get 1.3. Now I'm going to put a dot in for the 7 so it makes it a decimal right away, and it sure does. I get 1.3. So I know I've done it correctly. So I go over 7, I go up 1.3. Now I graph. This parabola is going to be a little wider, but it definitely opens up. So the range is y is greater than or equal to, because it opens up, and I look at the y value on my vertex. It's greater than or equal to 1, because this line never goes below the 1. It never goes below this bottom point right here. Okay, we try this next one. In our table, I have -3. What's one number lower than -3? Thank you. Good work. What's one number higher? -2. Those are the numbers I'm going to put in. When I put in -3, I should get 0. I'm not actually going to put it in this time. I'm going to just believe I've done it correctly, and I'm going to put in the -4 right away. So on the calculator, I go Control, divide, -3 over 2, parenthesis, -4 plus 3 squared. And in case, I'm going to put a dot on so it gives me a decimal onto one of the things, and it gives me -1.5. If I've done it right, when I put in the -2, I should get the same thing. I change this to a -2, and I get -1.5. So because I got the same thing, I feel good that I'm able to graph this. I go to -3, 0. Then a -4, -1.5, -2, -1.5. The range is y is what? Less than or equal to 0.